Good afternoon, everyone. Today we're going to be going over electro-hydraulic actuators for aerospace applications. I'm Brad Belote, the Director of Sales and Engineering at ZMAR Corporation, and I'll be conducting this training today. We're going to be covering a number of topics, including hydraulic cylinders, linear position sensors, proportional valves, and motion controllers. Electro-hydraulic actuators, simply put, provide very precise, high accuracy, high power density force for positioning and testing applications. So some common applications that we see out in the field are fatigue testing, compression and tension, load testing, structural integrity testing, hexapods, vehicle simulation, calibration, and even overpressurization and cavitation testing for fluid systems. So going in, we'll start with hydraulic cylinders. So hydraulic cylinders are the actuators that are going to be doing the work in these applications. So they generate the force required in compression or tension. So it's all linear. So force is calculated by pressure multiplied by the area of the piston. As well as if you look at the retract force, you will have to remove the area of the rod diameter, but that's only in tension applications. Some design considerations you'll want to be looking at are that force calculation that you will need for your test application, the velocity required in the application as well, so the speed that you're going to be moving at, the orientation of the actuator and the footprint available for the hydraulic cylinder is also important. If it needs to be compact or needs to be a special design or fit within a special dimension, that is definitely something you need to know. Side loading and deflection are always going to be considered when you're sizing your hydraulic actuator, and that is determining the rod size or if there's a stop tube necessary for the application. So we'll also want to know the stroke required, and that's going to be the length that cylinder moves back and forth. And lastly, we're going to want to know if that's going to be a single or a double rod cylinder in this particular application. So the primary cylinders used in these applications are going to be tie rod cylinders. And today we're going to be featuring the Parker 2H and 3L heavy duty and medium duty cylinder offerings. So the 2H is probably the most versatile tie rod cylinder from Parker Hannifin. It's available between 1.5 inch and 20-inch bores, pressure rating to 3,000 PSI, has a tie rod design just like the 3L. Has a variety of mountings. These are all NFPA mountings, so they're going to include your spherical bearings, your flanges, trunnion mountings, etc. And they're going to be used in tension and compression applications. Similarly, the 3L cylinder from Parker is going to be the medium duty, so it's only going to be rated to about 1,000 to 2,000 PSI, depending on bore sizes, which are available between 1.5 inch and 8 inch. It's a similar design and offers similar features to the 2H series, but will be used for more medium-duty applications. On more of the specialty side of Parker's offering, they offer fatigue testing cylinders. So this is going to be their FAST series. So FAST stands for Fatigue and Static Test Series. These are used in high-frequency applications as they have a low-friction piston and rod design and a chrome-plated cylinder bore to accommodate any kind of high-cycle testing that you'll be doing in an application. Custom cylinders are also available, and these are going to be designed specifically for your application. So you're looking at large bore cylinders, high pressure ratings, unique mounting designs, you name it. It can be done, and these are manufactured at the Parker's facility in Eugene, Oregon. This slide is actually just a complete overview of the hydraulic cylinders that are offered by Parker Hannifin. So you're going to be looking at the 2H and 3H cylinders, which we just covered, as well as the 2H and 3HX. These are the same as the 2H and 3H, but they offer a linear position sensor for feedback. So those are actually the ones that we'll most commonly see in testing applications. The CHD and CHE cylinders are going to be very compact cylinders used for very short stroke applications. The RDH or round line cylinders, the 3L we just covered was medium duty. The SAT is a telescopic single acting cylinder, so these are also available. Not as seen as often in testing applications, but it is available. And then the VH series is a high velocity hydraulic actuator. So these are going to be designed specifically for very fast moving cylinders, and they're going to come with an extra long cushion on either end. Lastly, we're going to be covering this a little bit later on in the presentation is the Haas 500. This is a hydraulic actuator that's more of a hybrid actuator. So we'll kind of get into what that means in a little bit. So these are the sensors that are most commonly seen in applications. You can have string pots, LVDTs, Hall effect sensors, optical sensors, magnetostrictive sensors, and there's actually many more other than this, but these are the ones that are most commonly seen for testing applications. You're going to want to be looking at the resolution and accuracy, the redundancy in an application if you need a confirmation of where the stroke is in the hydraulic actuator. That's where redundancy kind of comes into play. Repeatability and hysteresis, that also kind of plays into accuracy when we're looking at hydraulic actuators, as well as the desired output. This would be if you want an analog or a digital output. So like 4 to 20 milliamp, for instance, versus the SSI, or even like a Profinet, Profibus, etc. Environmental operating conditions and vibration and shock, they both kind of go together. You're going to want to know the exact environment that this cylinder or this linear position sensor will be in and what kind of, effects that it will be seen out. So typically we will recommend for applications in testing are magnetostrictive sensors. This is by the MTS line that we carry, and these are going to be ultra high resolution with accuracy down to about half a micron, excellent linearity, about plus or minus 0.01% of full stroke. So excellent repeatability, very low hysteresis, and a rod style design for gun drilled sensors, as well as a profile design for retrofits in the field, or if you just need an exterior mounted sensor. Redundant sensors are available in magnetostrictive sensors, as well as different outputs. So quite a variety of outputs in terms of analog and digital outputs. And they also offer electronic housing for environmental and vibration conditions. So that could even include explosion proof, or if there's any kind of high vibe application where the cylinder could be ramming very hard against some kind of surface. So the way these magnetostrictive sensors work is the sensor sends a signal down a waveguide and then gets the signal back from the magnet. So it kind of sends a pulse down that waveguide. Once it senses the magnet, the pulse comes back down to the electronic head, where that sensor knows the exact linear position of the hydraulic cylinder. So kind of what we're demonstrating here is typically what you would see in a gun drilled sensor or a gun drilled style sensor that is in a hydraulic cylinder. But again, this could also ride on the profile of the sensor where it is connected to a hard point outside of the hydraulic cylinder itself. So it could even be on the test article. It could be on any other point that's riding along that hydraulic cylinder, as long as it moves right with it. Next are the proportional valves. So proportional valves produce a hydraulic output, so flow and pressure, in proportion to an electrical input. So that's going to be volts or current. So some design considerations are always going to be the pressure and the flow of the hydraulic system, acceleration and deceleration required, the frequency response times. This is the time for the spool to shift completely from one side to the other, the hysteresis, the deadband, which is the mechanical overlap of the spool, which we'll be addressing in a few slides here, the repeatability of the hydraulic valve, and the capacitance of the hydraulic cylinder. And that's going to be how the natural frequency of your hydraulic system affects that proportional valve in your particular system. So why do we use a proportional valve over a servo valve for testing applications? So proportional valves are significantly less expensive, making your initial buy-in and even operation and maintenance after the fact is going to be a lot less expensive than a servo valve. It only requires about 10 micron filtration as compared to 1 micron filtration for servo valves. So it's a little bit looser of a spec. It can tolerate a little more particulate debris. It easily mounts to the top of a C-top subplate. So any kind of DO3 pad or DO7, depending on whatever size you're using, you can mount a proportional valve to it. And it actually sports a higher responsiveness on the higher end offering. So on Parker's top of the line product, it will actually have better than servo performance in terms of higher hertz, higher frequency capability. So servo valves, when are they better used? So really they're better used for the original purpose that they were designed for, which is flight applications on aircraft. as they consume very little energy and are very lightweight. But given that we are mainly just using these for on-the-ground applications, there really is no need to spend the extra money and have the extra headache of dealing with servo valves. So today we're going to be talking about the DF Plus proportional valves, which are the highest performing valves on the market. This is on the Parker's highest end offering of proportional valves that they even have available. So they offer a zero lap spool, a very high response time, so plus or minus 3 milliseconds for full stroke of the spool, very high frequency response of 350 hertz, mounts to a standard C-top subplate, has very low hysteresis, and they do offer underlap and overlap spools, although we don't see them as much in hydraulic applications. Pressures go to about 5,000 psi for these, so they can be used for higher pressure systems as well. So how does the valve achieve this performance? So that's going to be an answer that's in the voice coil in combination with the zero lap spool offering. So the voice coil is a coil that allows for precision movement of the spool. So that coil is going to be pushing that spool very precisely as there's an LVDT that has high motion control feedback built into the valve itself. So there's a mechanical connection between the coil and the spool directly, which is going to be moving that spool from side to side. Again, very high accuracy, very high precision for these applications. So an example of the spool is to your right there is going to be the zero lap spool. So a zero lap spool is a spool that's precision machined to the exact dimension of the A and B ports, improving deadband and performance characteristics. So you can see since the spool itself is cut to the exact dimension of the cavity in which it's placed, it can move very precisely from side to side, allowing for metering of even drops of oil through that system. There is a little bit of leakage on the, around the spool itself, but just enough leakage to accommodate lubrication of the spool. So moving on to hydraulic motion controllers. Hydraulic motion controllers are dedicated motion controllers that provide closed loop control to the system. The Delta motion controllers allow for the most precise hydraulic motion control. With the hardware, you'll get their best-in-class program and algorithms that outperforms PLCs. And this is mainly because PLCs operate different checks and I/O throughout the system, whereas the Delta is a simple, dedicated hydraulic motion controller. So it's going to be doing all of the motion control for your hydraulic system, and that's all it's focused on, but it does it perfectly. So for high precision test applications, we always recommend it. The Delta integrates nicely with LabVIEW and can also be run as a slave off another system like a Beckhoff. So we'll go on to Parker's hybrid actuator system. So the hybrid actuator system is the Haas cylinder. So the Haas cylinder adapts electromechanical concepts with a hydraulic actuator, which delivers about 3 times more power density than electric cylinders. With a plug-and-play kind of simplification, the result is an all-in-one actuator system that eliminates the need for a hydraulic power unit, hoses, and valving. So the Haas system is mainly just a hydraulic power unit, reservoir, manifold, and cylinder all built into one unit. And it also includes a linear position sensor, in which case in these applications, you will be using a magnetostrictive sensor. So since all of these are combined into one, for single point of use applications, there's really no better solution as long as it meets your power density requirements, your speed requirements, etc., which we can help you guide through. The Haas cylinder is just, excellent for these kind of applications. Also, when you're thinking about low maintenance, these are really, you can't really beat them because they're all integrated in one, meaning there's no leak point. And, maintenance on that hydraulic reservoir, they don't even recommend changing the hydraulic oil out maybe once every 5 years. So it's a very low maintenance kind of product there. And it also delivers the same performance as a proportional valve in these applications as well. So some additional considerations when you're looking at hydraulic actuators are going to be accumulators in the system, which are going to provide additional flow or pulsation dampening. Manifold customization for the hydraulic actuator, as well as integration of additional sensors into the system. So any kind of load cells, transducers, etc., that you're going to want to see in your system. You also want to know if you're going to be installing PO check valves or counterbalance valves, and that kind of has to do with the load holding in the application. So it's a lot to consider all in one kind of bit, but we're kind of going through and just touching on each little thing in this training here today. So just as a reminder, Z-Mark Engineering is here to support all your guys' fluid power needs, whether it be electro-hydraulic actuators, hydraulic power units, manifolds, or even complete test stands. To get started, just reach out to one of our team members with your application, and Z-Mark Engineering will review the application and get back to you with any pertinent questions or information. From there, we'll design a solution for optimal efficiency that can be delivered in the time frame that you need. So let us take care of the heavy lifting and set you up right. So just so everybody knows, our locations, we have 4 locations in California, as well as representation in Arizona. So we can cover the whole state pretty closely, shipping within one day. And our engineering team is always available at our Los Angeles headquarters. So anytime you need to contact us, feel free to reach out. sales@zmark.com. We have a chat function, zmark.com/chat, or our phone number is 323-721-5598.